So good morning, I am Anitha from Department of IT. Today we are going to see data structures. So as we all know, data structures, it is an effective way of arranging data. Because in computer we should have a particular structure for arranging the data. So if the data is arranged sequentially, then we can easily retrieve the data and manipulate it, and then again we can store it. So we need a particular data structure for it. So here the data structures, commonly known data structures are array, stack, on queue, and these are the common data structures we are using even today in our systems. And another one is linked list architecture also. So here in this session, what we are going to see is only about the stack and what is stack ADT and what are its applications. So since we covered all these in the previous lectures, here we are going to see only about stack and what is stack ADT and what are all the applications of stack ADT. So what is a stack? Again, this is also a type of data structures where we can effectively store linear data, or you can say it as a sequential arrangement of data. So here, if we take an example of a stack of coins or arrangement of books, so this is the best example for stacks. Here all the operations will take place only at the top. All the operations, in the sense we will have only two operations, push and pop. Push is for inserting a data and pop is to delete a particular data. So both the operations, that is push operations, this also will take place at the top of the stack, and pop operation, if you are going to delete a data, that also will be only at the top of the stack. Why? Because we are arranging in a sequential manner, one above the other. So this is called stacking. So in this stack, we'll have a concept here, last in first out. So the last inserted data will be deleted first, that is last in first out. If you are take an example of keeping the records for corrections, all the books will be placed here. So the one who have submitted at last, that record will be corrected first. So that is the best example for the stack. So last in is your first out. This is the policy of stack. So both the operations push and pop will take place at the top of the stack. Let's take an example of implementation details of a stack. We'll have, this is our index for a stack. Let's take this is your maximum size of a stack ADT, stack array. So here, first step is to initialize our stack. So while initializing, the top pointer will be placed somewhere here. For any stack, we need a pointer. That pointer we can take it as top here. So the top pointer, for initially it will points to -1. So when you initialize a stack, that is when a stack is empty, the top pointer will points to -1, or you can say it is a null. For our problematic explanation, we will take only as -1 now. So if you are going to do operations, the operations what we have seen is only push and pop operations. So if you are going to push a data inside the stack, let's take any number, push of 3. So we have already seen that all the operations, both the operations push and pop will take place only at the top of the stack. So here we are going to insert a value 3. So now the top pointer is pointing at -1. Only if the top pointer moves to the particular index, then we can place that value. So here, that we'll see in the algorithm. But now, just if the top pointer is pointing here to the starting index 0, so top pointer is now pointing at 0. So then you can push the value onto that index pointing that stack. So here the top will have the index 0. Okay. And next, the pointer will be incremented. Once after the insertion, the pointer again it will increment. So now the pointer will point to the next index in the stack. Again, if you are going to insert another variable 4, so this here push of 4. So now the pointer is pointing to index number 1. So top pointer will point to index number 1 and the value will be placed here. So now what happens if you are going to pop the value? So we are giving only pop without the value. I didn't give any index value here. So if you call this pop operation, now the pointer is in the index 1. So I'll place a pop operation here. Pop deletion. So the last element which have been inserted is 4. So that data will be deleted out. If you call the operation pop, so the last added element is 4. So that will be popped out. Okay. So that element will be popped out and the top pointer will be decremented to 1. So if you decrement a pointer, again it will point to the index 0. So now it is pointing to the index 0 and it has the value 3. Again if you give the again pop operation, so this operation the value will be 4 here, and if you again pop, the index is pointing to 0 and this value will be popped out. Okay, next the value will be popped out here is 3. What about the top? Here for the first one the pointer was in 1 and here the top pointer will point to 0. After this, after popping this, again we have to decrement one more time. So again the previous one, the stack is empty, right? So the top pointer will points to -1. So -1 is our initialization stage, that is where the stack is empty. Okay, so this is all the operations of push and pop operation in a stack. So next we can see what is stack ADT. So we know now what is a stack and what is the example and what is the operations and what are the policy, that is last in first out is the policy of stack, and now we are going to see stack ADT. So what is this ADT means? This is an abstract data type. So what is mean by abstract? Abstract it is like a gist or it is a brief like that. So here we'll in this stack ADT what we are going to describe is only the operations of the stack is visible and the implementation details is hidden. Implementation details are hidden. So abstract is we are going to show only the essential data and the not necessary data or unnecessary data will be hidden. It will be present but it will not be the consideration for us. That is meant by abstract. So here the operations what we have discussed about stack is push and pop, right? Operations are push and pop. So we will concentrate only on the operations of the stack and not the implementation details. So that is meant by the abstract. So here in the abstract data type we are going to dealing only with the operations. So for that operations we have to know two algorithms, is empty and is full. Okay, so for any empty stack, if the stack is said to be empty, means we know that for the previous example, if the top pointer points to null, then it indicates that the stack is empty here. So this is our previous example and this is your maximum size. So here if the top pointer points to -1, that indicates that the stack is empty. So here if the top pointer equal to -1 is this is a Boolean function, so it will return only true or false. So if this is the condition, the top pointer is -1, then this operation empty is true, right, for the stack, so it will return true, else return false. Okay, so this is your stack ADT operations. If it is empty now, then this top pointer should point to -1, that will return true. Otherwise if the top pointer is not -1 and if it is pointing somewhere here or here, it will return an index value either 1 or 2 or 3. So then it will return false, which indicates that it has some data and it is not empty. So what is the condition for is full? So if the pointer, so if that again the same top pointer reaches this maximum size, then that should be full. But in this case what we'll say is, for any stack the last value will be null. Okay, this way we have seen already in queue and array, this last factor will be null or 0. So if what we have to consider here is maximum size -1. If the top points to maximum size -1, so maximum size is this, so it should be one size ahead here. If the top pointer is pointing here, one size minus the maximum size, then this is to be full. Otherwise it is false. So these are the two algorithms you have to see for this operations of stack ADT. And for push and pop operations, we know that you can see an example later for this push and pop operations. So for this, if the stack is empty, you can go for push operation. When the stack is empty, this is a condition to be checked for push operation. If the stack is empty, then you can push the data inside. Okay, so here if it is full, then pop operation can be performed. If the stack is full, then you can perform this pop operation. So these are the two conditions, and these are the two algorithms we will see for performing these two operations of a stack. So this is about your stack ADT. Now we can see the applications of stack. So now we have seen what is stack and what is the example of stack and what are the operations of stack and what is stack ADT, and now we come to the applications of stack ADT. So for any data structure, the application is very important. So we have learning that is data structures like array, linked list and stack. We have to study only the applications mainly. So for this Many examples are there. The simplest example here is for string reversal. The simplest way we have learned already is string reversal. Let's learn the string reversal with an example here. So if you take a string as hello, okay, the string as hello means we have to reverse the string. I think we have learned in C and Python for reversing the string using any functions. So that again a variable to store the reverse of string here is string 2. So what obviously will have be, it has to print from the last letter. So this should be the output. So how this can be done using this stack? So this is here, we are going to see the string reversal using the stack ADT. So this is your stack, okay, stack ST. So here we are going to insert the string hello. So the again push operation will be performed for this string. So first H will be entered, again you have to push E and L and L O. So this, now the top pointer will be pointing at 0, 1, 2, 3 and 4. Okay. So to reverse the string, we know that all the operations of this push and pop will take place only at the top of a stack. So for this output, using this ADT, we are going to do pop operations. So for pop operation, it will return the last inserted value is O, and then another inserted value is L, here L and E and H. So this is your output string number 2. So this is how we have to use a stack ADT for reversing a string. So this is a simple example. Then another example is, this is example number 1, and example number 2 is for evaluating the arithmetic expressions. If you are going to add, if you give the expression like this, so this is considered to be an arithmetic expression for adding any two numbers, and this is your operator and these two are operands. Operand and this is your operator. So here we have seen the arithmetic expressions. So for these arithmetic expressions we have 3 types. So I have written the syntax for each type: infix, prefix and postfix. In this, infix is the human readable format and these two are for system readable format. So here the operand 1 and operand 2 with an operator. We have seen an example, right? 2 plus 3. So here these two are operands and this is your operator. So this is the human readable format. For prefix and postfix, what you have to do is the operator, for prefix, the operator should come first followed by the operands. For postfix, operands will come first and the operator at the last. So this is an example with the numbers. Here if you take any two variables, P plus Q, same thing. So here it will be for prefix, it will be operator proceeding and then the operands will be here, and for postfix, operands will come first and the operator will go second. So we can see a simple example for this. If you take an example of A plus B star C, this is an infix format. We are going to convert this to prefix and postfix. So first we will see the prefix. So prefix, for prefix the operator should come first and then followed by your variables or your operands. Okay, so operator and then the operands. So here if you take this expression A plus B star C, so this should be Parenthesis is your higher precedence of operator, so we have to evaluate this first. So here we are going to take out the operator first, followed by the variables or operands. So this has been evaluated with the previous one. Now this is my operator and these two are my variables. So here I am going to take the operator outside, followed by the operands or the variables. So this is my prefix statement for this infix statement. So now we are going to see the postfix here. Postfix is variables or operands. Okay, operands first and then followed by the operator. So operator should come at the last. So we take the same example here. Now we are going to evaluate it. So here a plus, and first we are going to evaluate only within the bracket first. So the operator should go last. Okay. So now this is my operator and these two are my variables. This should go at last. So a. So bracket you cannot consider here. So the say full operand and this operator should go at the last. So this is how we will evaluate the expressions from infix to prefix and postfix.